Hi guys, it is a gloomy day here in the collapse of global industrial civilization in the Green Mountains of Vermont. But we're going to head out, I believe, to Los Angeles, California today, where I have the great honor of someone I cannot believe I have never spoken to before, and this is environmental journalist Robert Hunziker. I hope I pronounced Robert's name right. And if you are any sort of a reader, as I am, and you need to be, of collapse of industrial civilization.com, you are probably also a fan of Robert's, where Robert has all sorts of articles. I think most of them originally published in UK Progressive on all sorts of subjects about how this planet is collapsing and on various fronts, from the Arctic Ocean to Fukushima to the pesticides nightmare unfolding in what he refers to as the Great Acceleration. And this is one thing we're going to be talking about with Robert. So Robert has promised me a riveting 45 minutes where I'm just going to turn this over to Robert, and where he is going to talk to us about 3 monster events happening to our planet right now that will have the impact of a giant asteroid collision. These 3 monsters are now in the process of colliding. The first monster is a state shift that is inclusive of the Great Acceleration. The second monster is human-caused greenhouse gases altering the planet. And the third monster is the collapse of ecosystems 100% due to human footprint. So Robert Hunziker, say hello to the folks and dive right in wherever you see fit.
Okay, great. Hi, Sam, and hi to all of your subscribers. This is great. I'm really pleased to be able to talk to you today. I really prepared a travel log, and that travel log is going to be inclusive of, we're going to travel the globe. We're going to look at flare-up ecosystems and ecosystems that are already in the process on a real-time basis of starting to collapse all around the planet. And one thing to keep in mind when we talk about climate change that a lot of people, I don't think, are fully cognizant of, and that is, it happens where you don't live. That's where it all starts. Who lives in the Arctic, Antarctica, Greenland, the ocean, Patagonia, the glaciers in the Himalayas, or the glaciers in the Andes? Nobody. So that's one of the things that trips people up when they talk about climate change. They get up every morning, look out at the blue sky, and it's a nice day, and they yawn and say, this is a great day to go. I don't see a big problem with climate change. Of course they don't. They're not where it's happening. So we're going to isolate and talk about those very things. And as you led in so properly, there are 3 major, what I call monster events happening to the planet, and they will have the impact of an asteroid collision. Do you remember the last time we had an asteroid collision? Of course you don't. It was 65 million years ago.
I was a baby in diapers when that happened.
I bet you were. That asteroid, by the way, happened to be 7.5 miles wide. And I think today we've got one hurtling toward Earth that's much bigger than 7.5 miles wide. But let me just give you a real synopsis, a quickie of what happened when that asteroid hit. We all know it wiped out the dinosaurs. Now, the first result was massive darkness and cooling of the planet. Temperatures dropped, plummeted 18, 20, 30, 40 degrees. The reason for that is that the vaporization of the sulfate rocks put all this atmospheric sulfuric particles into the atmosphere and blocked the sunlight. So you have that first. The second result is that you had excessive CO2, carbon dioxide, and it was derived from vaporization of the carbonate rocks, and that brought about warmer temperatures and too much CO2. Now, here's what's so interesting about this. It took 100,000 years, and CO2 increased at the rate of 0.2, that's 0.2 of a part ppm, parts per million, per year, and temperatures went up 5C, which we couldn't handle today if it happened, by the way. Now let me tell you the real interesting part. I just said that CO2 increased 0.2 ppm. Guess what rate we're at?
You're about 3.0 per year, or more than 3 per year probably by now, don't you think?
Yeah, absolutely. So what's happening then is humans are 15 times faster and more powerful than an asteroid. That's the point I want to make. We're 15 times more powerful than that 7.5 mile wide asteroid. Now, these three events, I'm going to just quickly name them off again, and then we'll delve into each one separately. But the first is we're approaching this state shift that you mentioned in the biosphere. And the biosphere is the zone of life. It's everything from the bottom of the ocean to the top of the mountains. It alters the ecological web when it happens in a negative fashion. The whole thing is due to the human footprints. And this human footprint, when it exceeds planetary boundaries, causes this state shift. We'll go into that in a minute. The second monster event is that human-caused greenhouse gases are altering the planet. In some cases, this is happening exponentially. For example, in the ocean with acidification, it's happening exponentially. It's disrupting the entire Holocene period of the last 10,000 years of our wonderful, wonderful Goldilocks climate. Not too hot, not too cold. That's coming to an end. Now, when I talk about exponential, I think I just want to give a quick explanation of that because it's crucial on what's happening today. If I take a walk across the room to a water fountain and take 30 linear steps, that's 30 steps. Whereas if I took 30 exponential steps, I would circumnavigate the planet. If I take another 10 exponential steps, I'm on Mars. So we're talking fast when it's exponential, and we have some of these exponential things happening in our climate system today. We'll talk about that. And remember, it happens where nobody lives. And you're going to see when we talk about various ecosystems in this planet of ours, think to yourself, hey, nobody lives there. They don't see it, they don't hear it, they don't smell it. Yeah. The third monster is that we have ecosystems that are collapsing. And this is 100% because of the human footprint and also destructive practices like excessive use of chemicals. So let's talk for a minute about monster number one, the state shift. There is a major landmark study that was done by 22 biologists and ecologists, a landmark study, major. They concluded that the world's getting very close to what they call a state shift. And what that means is when you have more than 50% of the ice-free land on the planet, when more than 50% has been converted to crops, to livestock, to towns, cities, baseball parks, airports, the human footprint, if you will, then the ecological web starts to collapse. And what's behind this? Well, clearly what's behind it is the great acceleration, which I'll talk about in a few minutes. You made mention of this, Sam. I wrote an article people may want to Google and read. I think it was one of my best articles ever, The Great Acceleration and Obliteration.
Yes, that's I'm my evil twin on that other channel is actually going to share that article on Sunday, but we don't talk about my evil twin in that other channel on this channel. But all right. Anyway, I will put the link to the Great Acceleration and Obliteration, which really sums up a lot of what I expect you're getting ready to say.
Yeah, exactly right. And I just want to read one of my favorite sentences that I've ever written, which is in that article, because it really tells the tale. Here it is. The Great Acceleration has taken off like a spaceship destined to hit warp speed, accelerating faster and faster. As this evolves, humanity risks becoming a bug looking for a windshield.
There's fewer and fewer bugs looking for windshields. So would you say, I don't want to already start interrupting you, but I've just been noticing, and have you been noticing the same thing, Robert, particularly since the beginning of 2018, that the faster than we previously expected You see this over and over and over again whenever you're looking at environmental news. You're seeing scientists are shocked that this, whatever it is,
everything across the board
is happening faster than previous. Is this all part and parcel of exponential change and the Great Acceleration?
Yes, it is. And, you know, that's another interesting fact. By the time they put together the facts for one of these IPCC meetings, Intergovernmental Panel on Climate Change meetings, it takes them, their data is 5 years old.
And it's already accelerated. Anyway, I'm really going to try to, okay, I'm going to shut up. Go into your spiel, Robert, and I will try to stop interrupting you.
Okay. So anyway, if anybody wants to look up this landmark study by the 22 biologists and ecologists about the state shift, all they have to do is Google the following. Where have I got the? Oh, okay. Approaching a state shift in Earth's biosphere. That was in Nature in June 2012. Approaching a state shift in Earth's biosphere. Now, here's the crux of the issue, in part. And this also has to do, of course, with the Great Acceleration. What is the inventory of productive land on the planet? Think about that for a minute, and I'll tell you what the number is. It's about 3 acres of ecologically productive land on the planet per capita for 7.5 billion people. Now, here's the problem. To support or sustain material consumption for the industrialized countries like us, developed countries like us, it takes about 8 to 12 acres per capita. So in other words, the ecological footprint of all the industrial/developed nations, and that's about 25% of the world population, they are taking up almost all of the available ecologically productive land. So 25% of Earth's people are consuming nearly 100% of our natural productive capital. Now, when you go beyond that, you're going to go into a deficit. And this is why 3 billion people on this planet live on about $2 or $3 per day. There's no room for them. Yeah. And let's make some room out of that top 25%. I don't think the top 25% is going to make any room. So there's another way to look at this, and that is that humanity is using the equivalents of 1.7 Earths for sustainability of our lifestyles. Almost 2 Earths we're using to sustain our lifestyles. So this state shift is on a collision course with the greenhouse gases, which are altering the planet, and the ecosystems which are collapsing. They're also all interrelated in an interesting, curious way. But let me talk a little bit before I go to the monster number 2, a little bit more about this thing about the Great Acceleration, because since World War II, this massive amount and increase of population is a bit like a watermelon moving through a snake, and it impacts everything. In the span of one human lifetime, our population went from 2.3 billion to 7.5 billion in one lifetime. It took thousands of years to get to 2 billion people by World War II. Thousands, tens of thousands. It only took 70 years to add another 5 billion. If you really think through that, and if you concentrate on that a bit, it's mind-blowing. It's mind-blowing. So we tripled the population in one lifetime. Here's some examples of what repercussions have been already, and these are really things that happen. For example, air pollution, as a result of the Great Acceleration, has already killed 30 to 40 million people on the planet, and that's more than the death toll from all the wars since that period of time. So air pollution's killed more people than wars. Another impact, and part of the reason for the air pollution, is the automobiles went from 40 million to 850 million.
I think it's larger. Are you sure it's only 850 million?
Could be higher.
I thought it was quite a bit higher, but
probably is.
Once you hit 850 million, you get to a point it just gets so ridiculous.
Probably a billion, but yeah. I took that figure out of the book, The Great Acceleration by J.R. McNeill. Now, I think that book was written, I got it in my hand here, let me see. No, there's the problem. That was written in 2014. That's 4 years old, so you're right. Yeah. It's much higher.
I'm pretty sure I remember reporting it's crossed well over. Anyway.
Yeah, the point I'm trying to make, though, is this great acceleration is just impacting everything. You look at carbon dioxide in the atmosphere; it's increasing. It's increased 8 times over the last 70 years. 8 times anything's a lot. Take it times your salary. If you get paid, 20,000 a year, all of a sudden you're making 160,000 a year. 8 times anything is big. So what we've got, because of this great acceleration, is humanity has become literally a vast experiment. Nobody's been there before, and we're going to find out what's happening. But we do know the impact it's having on our planet, and that's what we're talking about right now. So let's move to monster number 2. This gets really interesting because here you're going to see some real-time examples of this climate change monster taking place. Now, this is greenhouse gases altering our planet. And basically, it's the human use of fossil fuels that's disrupting this Holocene period, this wonderful Goldilocks, not too hot, not too cold climate. I mean, we've been spoiled like crazy with that one. The key driver to this planetary disruption is clearly carbon dioxide or CO2. I'm going to give you some examples to prove it to you that CO2 determines 100% what happens to the climate, what happens to weather, and what happens to extinction events. Now, for the last 40,000 years, CO2 into the atmosphere ran in a range of 200 to 300 parts per million. It was pretty comfortable around the 270 range for a long period of time, up until 200 years ago. And all of a sudden, it took off exponentially like a rocket ship. In 1850, human-caused CO2 into the atmosphere was 50 million tons, 50 million tons. Today, it's 10 billion tons. Today, it's 10 billion tons. And that number today increased itself and doubled over just the last 35 years. Yeah. So today we're at 400. Now, that's that acceleration thing, isn't it? Today, we're at 410 parts per million CO2 in the atmosphere. How does this affect the climate? We've got some great examples because the paleoclimate history has given them to us. People studied this. They've looked at ice core. They've looked at sediments. They've studied shells, seashells from ancient seashells, these things. They can tell where we were 15 million years ago. CO2 in the atmosphere was 400 parts per million. Sound familiar?
It does.
Yeah. Okay.
Can I mean, again, I'm really trying. When you're talking the CO2, you are what you're saying right now. Ignoring. Well, I know you personally aren't ignoring, but for the purpose of this conversation, you are not including the methane great acceleration either. I mean, I don't want to get off on that discussion necessarily, but I want to make sure people understand, are you or are you not combining the methane in with the CO2 in this part of your discussion?
No, I'm only talking about the CO2.
Okay.
Yeah. So 15 million years ago, we were at 400 parts per million. That's where we are today. We all know that. And what happened 15 million years ago is that temperatures were somewhere between 5 and 10 degrees warmer than today. Now, keep in mind when I say that the IPCC at the Paris Agreement a couple years ago, the nations of the world said, boy, we got to keep this thing below 2 degrees increase, or we're going to have all hell break loose. And then they said, well, not really. You got to keep it below 1.5 degree increase. We're already at 1 and something and change, by the way, or we're going to have a lot of problems. Here we're talking about 5 to 10 degrees warmer. What was the result 15 million years ago? Sea levels were 75 feet higher than they are today. So if that were the case, I'd be in scuba gear right now.
You're in LA, right?
I am in LA. So, but then let's compare this then to show you how dramatically this carbon dioxide affects our climate and weather to 20,000 years ago. Then CO2 was 200 parts per million, or 1/2 the rate we are today in 15 million years ago. Temperatures were bitter cold. Sea level was 400 feet lower. Florida was twice its size. That was the last ice age. Yeah. So if someone wants to tell me that CO2 doesn't have an impact on our climate and our weather and how we're going to sustain ourselves, they're crazy. Venus, our sister planet, 95% of its atmosphere is carbon dioxide. So they have a ppm of 950,000. You know what the temperature on Venus is?
About 600.
865 degrees. It melts lead. If you were to take a spaceship to Venus, you'd never land. You'd melt. Now, let's look at how some of these greenhouse gases in real time, are disrupting our planet. I'm going to start with the Arctic because it's happening faster there than anywhere else, although Antarctica is starting to catch up, unfortunately. The Arctic has been heating up 2 to 3 times faster than anywhere else on the planet. As a result of that, that gigantic ice cap we had of multi-year ice, which was 5, 10, 15, 20, 30 feet thick, it's gone. So that's the infrastructure of the Arctic that is gone. We now get a thin ice extent. It doesn't amount to much. The consequences of this happening, this massive change in the ecosystem in the Arctic, affects the entire northern hemisphere. There's a gentleman named Dr. Peter Glick with the Pacific Institute here in California. Do you know who he is, by any chance, Sam?
I've read some of the stuff that Peter's written. That's someone else I need to interview. So what is Peter's gist of what he's talking about?
I just want to give you a quote that he made about the Arctic. He's studied it for like 30, 35 years. A really wonderful guy. Anyway, here's his quote. What is happening in the Arctic now is unprecedented and possibly catastrophic. It's not possibly catastrophic, but it already is, because we've just lost the planet's biggest reflector. What happens when you have that multi-year ice up there, it reflects about 90% of solar radiation back into outer space. But what happens when it melts away, and we'll probably have an all-blue Arctic, certainly through the spring, summer, fall months before long, maybe within a year or so, then that dark blue background does what? It absorbs the solar radiation. Bingo, we got big problems on our hands. Number one, the Arctic weather patterns and change in temperature first affects the jet streams, and these are those westerly winds we've had forever at 39,000 feet altitude. Those get disrupted and they start to loop. If you remember when you were a kid, you had a top and you'd crank it up and it'd spin really nicely until it loses some of its speed and then start to loop. That's what the jet streams do when the temperatures changes so dramatically in the Arctic. And as a result of that, you get awfully horrible changes in weather patterns throughout the whole northern hemisphere. For example, you remember the massive floods in Colorado just a few years ago.
In Boulder, yeah.
Yeah, what they had is they had a tropical weather pattern. Tropical weather set in for 30 days and didn't leave. Well, we're not supposed to get tropical weather in Colorado, are we? But it happened. So that's what happens when the jet streams go goofy on us, and they're very goofy now. Jennifer Francis of Rutgers University is the one who's done the seminal work on this, and most scientists have really picked up on it. Second thing that happens in the Arctic that's very dangerous and extraordinarily dangerous, and maybe one of the most dangerous things we're going to talk about today, methane clathrates. And this is ancient methane. It's been frozen for eons in the seabed. This can cause, if it lights up, can cause runaway global warming, and we'll burn off all the agriculture so fast you won't believe it. The East Siberian Sea is where all the arrows point. The big red arrow points right there because they've got very shallow waters, 50 meters. Doesn't take much to heat that up. I'm going to talk a lot more about that in a few minutes.
I just want to make sure that people understand what you're talking about here is not the same as the methane being trapped in the melting permafrost on land. That's a whole nother wheel turning. Is that, am I correct on that?
Right on, and that's another ecosystem we're going to talk about, by the way. That's another one that's a big problem. This one up here, though, in the East Siberian Arctic Sea could be the walloper. Now, the third problem with the Arctic conditions changing so dramatically is it amplifies Greenland. And, you know, a couple years ago, the entire surface of Greenland turned to slush. It scared the bejesus out of these scientists, climate scientists who study it. Jason Box is the #1 climate scientist on Greenland. He's out of Denmark now. But
we remember his famous quote, but we don't use it on this channel. So the quote that got him in so much trouble when he was honest about the state of the planet years ago. Anyway,
he's a pretty cool guy.
Yeah, he is a great guy. I need to talk to him too. I don't think he talks to reporters much anymore, though.
Ah, well, way to go, Sam. Nice one. Okay, so here, now let's go to Antarctica. Let's go to the bottom
Yeah,
of the
let's
world.
do that.
We started at the top. Let's go to the bottom and talk about Antarctica, because I said Antarctica is starting to catch up with the Arctic, and it is. We're getting massive, unprecedented ice shelf collapses in Antarctica. These babies are huge. The Larsen ice shelf collapsed in 1995. The Larsen B collapsed in 2002. And just last year, the Larsen C collapsed, a 1 trillion ton iceberg. Because of that collapse, National Geographic's going to have to redraw the World Atlas. Now, what's the problem with ice sheet collapses? Well, ice shelf collapses. Ice shelf is just what it says. It's a shelf. It's not the continental land with the ice on it. It's a shelf that extends out over the sea of ice. It can be a quarter, half mile, sometimes a mile thick. And underneath, on the underneath side, it'll come back and connect with land, maybe a half mile, quarter mile, or mile back. Well, when these collapse, it's like if you're a hockey team and you have the goalie leave the net open, because these ice shelves hold back the big inland glaciers from flowing into the sea. Once you lose them, then all of a sudden these glaciers start to really roll into the sea, and that's where we now have, we just got an alarm here a couple of weeks ago, in fact, some scientists from somewhere in the UK were shocked to find out that the ice flow now from the glaciers is, I think they said 3 or 5.
Yeah, three times. One of these 3 times faster than previously thought as the Great Acceleration continues to accelerate.
They were shocked. Well, that, I think everybody on this call probably knows what that ice amounts to. That's 200 feet of sea level, isn't it?
When it all goes.
So let's talk about the consequences of ice melt. And I want to give you some real-time examples on this too. As far as mainstream science goes, they say that the sea level will rise by up to maybe 2 feet by 2100. That's probably really conservative. It's one of those things where they're about 5 years behind what's happening anyway. But let's talk about, it doesn't matter, because already we're seeing sea level rise problems right here in America, and I'm going to give you 3 of them right now. First, on the Outer Banks, North Carolina, the Outer Banks is a tourist destination. People love to go there because of the beaches and the wild horses and all that stuff. That's 200 miles, a chain of islands. There's a permanent population of 57,000 people. Several instances along those islands, the shores, the islands are down to 25% of their original width. Why? Sea level rise. The other thing you've got there that's interesting is there's an iconic highway called Highway 12 that connects all the islands, and tourists love to take it. It washes out all the time. Why? Rising sea levels. Miami Beach, they're raising the streets by 2 feet because of sea level rise. I'm going to give you something you can Google to see this and prove my words. If you Google the following, Miami Beach is raising streets by 2 feet to combat rising seas, you'll see an actual photograph of those streets being raised by 2 feet in Miami Beach. The third real-time example happening right here in America is we have, within the last year or two, America's first ever eco-migrants, our first ever climate refugees out of the Isle de Jean Charles in Louisiana. And HUD spent $50 million to move an entire community of people to higher grounds because of rising sea levels. So it's already happening. It's already happening in the most sensitive parts of our continent. Another casualty of global warming is the rivers, and this is very interesting. The Lantang River in China is called the Danube of the East. It's a major commercial waterway. You know, in China, they use the rivers for commercial purposes much more so than anywhere else in the world, in fact. And it goes into the Mekong River Delta. It's the longest river in Southeast Asia. It's like 3,500 miles. Travels through China and Myanmar, Thailand, Cambodia, Vietnam. There's a senior geological engineer in China named Cheng Hangding, who has spent a lifetime studying the headwater glaciers for the Lantang River. He announced that 70% of the headwater glaciers for that river are gone because of global warming. 70%. I guess the question is, what happens when the other 30% goes? You'd have an intermittent waterway, wouldn't you? Now let me tell you about a river that disappeared in 4 days because of global warming. The Slims River in the Yukon used to be about 1.5 to 2 football fields wide. It vanished in 4 days, right before the eyes of scientists, in fact, who were on field trips. It had flowed for hundreds, if not thousands of years, and this rapid retreat was because of the Kashkalish Glacier retreated so rapidly that it retreated beyond the headwaters of the Slim River. That waterbed now is dust.
Wow.
Another example of a problem with global warming and the alteration we're getting from greenhouse gases has to do in the Andes, the mountain glaciers in the Andes. The World Bank, of all people, the World Bank of all organizations, not too long ago put out a warning that 100 million people are at risk in the Andes. And these 100 million people depend upon the mountain glaciers in the Andes as their water towers for irrigation, for hydro, for drinking. Now, if you were to fly over the, I've seen photos of this, the Andes 30 years ago, they'd be very white. Today, if you fly over the Andes, pretty much bare rock. I was just in Colorado last week for a family reunion and flew over the Rocky Mountains. And I hadn't done that in a couple decades. I was shocked at how little snow there was. It used to be much more snow-capped. I'm seeing the same thing here. So we actually have entire civilizations at risk because of global warming, because these glaciers, glacial mountainous glaciers, are water towers around the world. So let's now move to the Amazon and talk about that for a minute. And that's the world's lungs. The Amazon rainforest is considered the world's lungs. Well, here's something alarming for you. Rain patterns to the Amazon are changing as this atmospheric warming comes along. It shifts the rain away from the Amazon. As a result, we've had back-to-back severe droughts in the Amazon. This is literally unprecedented. It's never happened before. 2005, 2010, 2016, unheard of severe droughts. That's unheard of throughout geologic history, by the way. Now, isn't there something interesting here? This came in threes every 5 years. What did I just say about Antarctica? It came in threes, but that was every 15 years. Isn't that a strange coincidence? I think so. Plus, there's another big problem in the Amazon. And that's this. During the time it takes for me to take you on this travelogue and trip around the world and talk about cascading destructiveness of ecosystems, day by day, month by month, the equivalence of 200 football fields of rainforest is destroyed by people. Yep. That's the market forces of globalization at work. So there's our lungs, folks. That's our lungs. Two things happening. One, we're chopping them down. And secondly, where we don't chop them down, greenhouse gases causing too much warming is shifting rains away from the Amazon. And you've had unprecedented back-to-back droughts. That's, I think, a real worry, if you ask me.
Can I just one more time be guilty of interrupting you? One of the stories, what I think is one of the biggest climate change stories of last year, and apparently no one seems to agree with me, as all eyes are on the Arctic and Antarctic, was this story. Maybe you can spend a couple of minutes explaining this to people, how scientists have now determined that tropical rainforests, instead of being these carbon sinks taking carbon out of the atmosphere, have been so screwed up by humans and whatnot that that tropical rainforests, which were supposed to be one of our great saviors, are actually now contributing as a source of CO2 into the atmosphere. Do I have that correct? And try to tell us a little bit about what that means in the real world.
Well, you unfortunately you do have it correct, and that the rainforests have hit a tipping point. We're going to talk in a minute about the ocean. The same thing's happening there, by the way, where these sinks we've had on the planet forever, and a sink really means that just what it sounds like. It absorbs a certain amount of this carbon dioxide that otherwise would do what? Would go up into the atmosphere. Instead of 400, we'd be at 600, wouldn't we? Whatever parts per million. And it absorbs it and stores it. And trees do that. You know, they use carbon dioxide. But the Amazon has been so disrupted in so many ways. And by the way, it's these back-to-back droughts that are really causing that more than anything, as much as the humans chopping them down. But when you have these serious droughts, that affects the entire Amazon. Mm-hmm. You know, not just where they're chopping them down. So that's causing the rainforest to lose its mojo. And it's no longer becoming a carbon sink. It's starting to expel this stuff into the atmosphere. That's the worst possible news we could ever hear, Sam. It's happening. So,
and I just don't feel like it's being talked about enough. I know whenever I do a story on it or what, I get like no comments about it. Like nobody responds, and I say, guys, this is one of the biggest stories on the planet of 2017. And anyway, I'm glad to hear that at least you agree with me that I'm not crazy, and that it is a pretty that this is an example of a tipping point that we have already passed. We're not running up against. We're over the tip.
Over the hump. You're absolutely right about that, and it's seriously a dangerous situation. And I'm just now, that leads me into talking a little bit about permafrost, because it's another victim of this whole global warming, too much CO2 in the atmosphere business. The Siberian region may be on the verge of actual collapse, and this would have temperatures scoot up as much as 30 degrees very quickly. That'd burn off all of our agriculture, and we'd all be dead ducks in that case. And there's that real risk of this. You know, Russian scientists have identified 7,000 of these pingos. I'm sure you've heard of these, Sam. Yeah. And what it is, a pingo, and they think there could be hundreds of thousands, but they've so far actually identified 7,000. It's like a mound of earth that comes up where the permafrost is, because the permafrost is warmed enough that it's activated. The methane, it wants to escape and pushes the earth up. In time, what happens with these pingos is that they fall in on themselves and become big craters, huge craters, emitting all of this methane. Now, if any of your people on this call want to look into it, the Siberian Times had a great article on this just in March of this year. And here's what they should Google. Crater formed by exploding pingo in Arctic erupts a second time from methane emissions. And they can read all about it. We got the same problem in Alaska, by the way. And in Alaska, we've already got a tipping point that's been exceeded. Scientists conducted a 2-year study. They used these low-flying airplanes, and they took a read on the amount of carbon that's being released by the natural biological sources. What they found out is that the permafrost in Alaska now is emitting the equivalent of 220 million tons of carbon over a 2-year period. Well, let me tell you what that equals. That's equal to all of the U.S. commercial emissions emitted per year. And we're one of the biggest carbon emitters. So now we have one of our own states, Alaska, in competition with human-generated CO2. Now, there's an article people can read on this if they want to Google this that will talk about this very thing in Alaska. Here's what they should Google. We all knew this was coming. Alaska's thawing soils are now pouring carbon dioxide into the air. That's a big, 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 gigantic problem. Now let's talk about the biggest impact of human greenhouse gases. I haven't even gotten to that yet. Now we're getting there. The oceans. Global warming is destroying the oceans. Here's why. The oceans have been, I should say, absorbing 30 to 40% of all the CO2 that's emitted. Can you imagine if it hadn't been? This is our biggest carbon sink. If it hadn't been absorbing that, where we'd be today?
And we're going to be when they do stop, when they cross the same tipping point in the tropical rainforests of.
Well, that's happening, by the way. The oceans also. Here's the other problem, big problem. They absorb 80 to 90% of the planet's heat. So we have been distorting, our whole global warming thing's been distorted dramatically because the oceans have been taking off about 90% of the heat. What if that stops? What if that were reversed somehow? Then where are we? So can you imagine if it hadn't been taking 90%? We'd be Venus. Mm-hmm. Now, there's a carbon sink theory out there right now by certain climate scientists. They say the oceans now have maxed out. Probably they've absorbed maybe 130, 150 billion tons of CO2. This goes back over the last 100 years or so. They think the oceans could be in a state where they're going to reverse and start now emitting CO2 into the atmosphere, much like we just talked about with the rainforest and with the permafrost. What if you have all these things starting to go through this tipping point beyond it and starting to now contribute instead of sinking? Wow. Here's another problem we got in the ocean. Remember I said this is the biggest impact of our greenhouse gas. There's several things going on in the ocean. The ocean's 2/3 of the planet. As acidification, we're actually changing the ocean chemistry. This threatens our sea life right to the base of our food chain. Pteropods, for example. These are free-floating snails. They're like a little pea in the water, almost microscopic. They reproduce by the billions and trillions. They're the food chain for everything from krill to whales. Salmon love to buy them to eat them to fatten up. Here's the problem. There's some scientists who only study pteropods and all of these basic things in the food chain. And in the Southern Ocean, they took a bunch of them out. They put them under a microscope. And you know what? Their shells are so thin that these pteropods were having problems maturing and reproducing. Yeah. That's a huge problem. Now, we have an oyster farm in the state of Washington, one of the best oyster farms in the world. And what they do is they'll take these larvae and they put them in water bins off this ocean and raise them, and then sell the oysters. A couple years ago, and then what they do is they bring the waters in from the Pacific to flow through those inland bays they've got where they grow the larvae. The shells weren't developing well. They did enough analysis and they found out they were bringing acidic waters in from the Pacific and they had to change their operations. That's not very good news, is it? Let's talk about the Great Barrier Reef for a minute, because my younger brother was just there in January. He's a diver. He saw what I'm going to talk about in real life. The Great Barrier Reef, that's one of the 7 wonders, natural wonders of the world. Warming kills coral, and 1/2 of the coral died in 2016-17. Scientists have literally freaked out over this. Yeah. Because of the extreme heat, they died. My brother was there in January and did some diving, and he was extraordinarily disappointed. There was just no color, not a lot of life where he was. Of course, it's a long, it was 2,000 or 3,000 miles long, but where he was extremely disappointed. And that's kind of a sad thing to hear, by the way. That's because of extreme warming in the ocean as a result of too much greenhouse gas emitted by people and causing the whole planet to warm up. The other problem in the ocean, and we got 3 more problems we're going to talk about in the ocean, is loss of plankton. Plankton production, and this just came out within the last 2 years or last year maybe. Plankton production has dropped 40% the last 50 years. That's the source of oxygen for our planet in harmony with the rainforest. Next problem in the ocean is the thermohaline, which is the ocean conveyor belt. Global warming has slowed it down. It's probably the slowest it's been in 1,600 years. This is that deep water current circulation around the world. So, like you've got the jet streams for the northern hemisphere, the thermohaline is the deep water current that circulates around the whole world. And what happens, and one of the risks is this slows down, is it threatens the temperate climate in Europe, because Paris is 49 degrees north latitude. North Dakota is 46 degrees north latitude. So it's North Dakota on the globe is farther south by 3 degrees than Paris. But yet in January, Paris's average temperature is 38. North Dakota's is 12 degrees, and they're south of Paris. And the reason for it is that the entire European continent is benefits by this thermal haline ocean conveyor belt that brings up the tropical warm water right up along the coastline. Well, that's starting to slow down. Kelp is another big problem. We talked about the rainforest. Well, kelp is the underwater rainforest. It's the equivalent of it, if you will. Global warming is killing off massive amount of kelp forest. In Northern California, the bulk kelp forest has been denuded along hundreds of miles.
Yeah, I've been documenting that in real life with my camera the past couple of years, the tragedy of the kelp. You know, I hate to say that I'm enjoying this conversation. But we are already 45 minutes into this laundry list of how things are looking in the opening bell of the summer of 2018. But we're down to like 10 or 12 minutes. So just give us your. Let's move ahead the clock from 2018 to 2050. And Robert Hunziker, what is your vision of faster than previously expected? Just give us your 10-minute snapshot of planet Earth in the year 2050 and humanity and the planet.
Well, have you seen the film Mad Max?
Yes.
Okay, there you go. That's kind of where we're going to be, I think. Now, relative to that, I want to just talk for a minute about the Stern report that was commissioned by the British government in the year 2008. The reason I want to talk about it, it was the first ever major undertaking to project the worst case in climate change, assuming business as usual. Mm-hmm. It's a seminal document, 700 pages, real serious stuff. Here's what they said. Here's what they came up with 10 years ago. And then I'll talk about going ahead. They said the sea level rise will be 15 to 20 feet within a few decades. This assumes business as usual, right? 15 to 20 feet in a few decades. Florida, New York City, London, Tokyo will be underwater. 1 billion people will be displaced, sick, or dead. You're going to have massive water and food shortages, and food and water wars will reign throughout the planet. That's that dystopian existence like Mad Max that I talked about. And that's where you are. That's where we're headed. I think that's the next 50 years out. That's where we're at. I think you're going to have a very, very elite class, the transnationalists, I call them. I wrote an article about this once. The transnationalists are all the richest people on the planet. They all know each other. They all go to the same conferences. They all go to the same hotels, ride the same jets and things like that, and know each other and work together on things like building offshore cities, for example, like Peter, what's his name, is doing now, of PayPal fame. And I think that they're going to be setting up kind of resort areas for themselves. They may set up some in Antarctica, where you may have palm trees on the shoreline by then in Antarctica. Everyone's going to want to go there because the mid part of the world is going to be too hot. Life won't be able to sustain in the mid regions of the world. But you'll still have some life in, extreme regions, extreme latitudes, north and south. I think most people are going to be just kind of workers, grunt people, just trying to get by, probably in roaming gangs and things like that. I know this sounds bizarre, but it's the way I see it. I see it exactly like the Mad Max film, where you have, in fact, we already have this happening today, by the way, to a certain extent. You have massive eco-migrants right now who are fleeing northern parts of Africa because it's dried up so much. The whole Mediterranean coast on the east and the southern portion is dried up faster than anywhere else on the planet. And it's not just migrants coming from Syria, but it's along that whole coastline. And they need to go somewhere where they can feed themselves. Syria, by the way, is an interesting case because we've now determined, some people have, it's a climate-generated war. They had a 6-year drought that chased 1.5 to 2 million people. Well, I think it was about 1.5 million farmers and herders off their land because they couldn't use it any longer. Well, for God's sakes, this is the Fertile Crescent. This is where Western civilization started, the Fertile Crescent. They were driven off their land. They had to go to cities to try to find a way to make a living and eat. And that caused major social disruption around the year 2011 in Syria. And a lot of people think that led to the civil war that, took off from there. So we're already seeing it. We're already seeing it because of the climate. We're seeing the climate wars already. And that's where I think we're at. And it's very unfortunate because, listen, Wally Brecker was the godfather of global warming. He's the man that coined the term in the 1970s when he was at graduate school in the 1950s at Columbia. And he's still working there today at the Lamont Laboratories. He's in his 80s or 90s. But he said that back then, that 80% of our energy was powered by fossil fuels, and the other 20% came from everything else, whether it be dams or whatever it may be. He said, guess what? Today it's the same ratio. 80% fossil fuels today, and 20% is coming from now renewables and all these different things. We haven't made any headway. We're still increasing fossil fuel plants and stuff by 3% a year. They're not tearing those down and putting up a bunch of renewables. It's just not happening. It's not going to happen, especially with the United States' sour leadership in the world marketplace today. The worst thing that could have happened to this planet ever, ever, ever in my lifetime, is the election of Trump as president, to be honest with you. The worst thing that could happen. And we are in a tailspin as a result of it in so many ways. And I've written about this. I've written about, is the EPA bad for your health? I wrote an article, and it's true. It is bad for your health now. So I'm not very optimistic, unfortunately. And it's just a reality. And I didn't even get into the loss of insects.
We can. One question I always like to ask people, since we're in the waning minutes of this, where do you see the population of planet Earth by the end of this century? I know you've studied this question. I mean, no one knows, but what is your highest and best guess? How many,
by the end of the century?
Yeah, where?
Oh, maybe 2 billion.
You think about 2? So you're
1.5 to 2 billion, yeah.
So where are all the rest of those people going? That's what remains to be seen, I guess.
Well, they'll be, basically be dying off. The planet won't be able to support them. We won't have enough room in the planet. We don't have enough room now. Imagine what happens if you start to burn off the whole mid latitudes, and because of the global warming thing's not going to stop. I'm sorry. There's no way. Now, I know the geoengineering people are talking about you got to do this and do that. You know what? There's not one of them that we know that works yet, and the unintended consequences could be worse than what they're trying to do. That's tricky stuff. I'm on a thread with a bunch of scientists. I don't add to it, but I get to read their stuff, who are talking about the geoengineering thing every day. All these papers, I see them. I can't even read them. There's so many. Bottom line is, no one's there yet, and they don't know if they can even get there. Now, Bill Gates has put up some money, and they've created this thing to absorb I forget how many tons of CO2 per year. It's a very complicated thing. Wow. Here's the bottom line on absorbing CO2. You have to put up as much infrastructure absorbing it as put it out there in the first place. Imagine that. Think of the infrastructure for the fossil fuel industry. You can't do it. So, we're kind of in a bind here. Unless you get a Marshall Plan, if you had the right president, the right leadership tomorrow, if you got a Marshall Plan and said, if we can go to the moon, by God, we can come in here and get rid of fossil fuels and make this planet work and hopefully save our asses. That's what you need.
Is that going to happen?
No, it won't. There's just too much selfish interest in the planet. Plus, here's the other problem. People don't take it seriously. Remember what I said, the motto of this whole story we've got here today is, it happens where nobody lives. And if you don't see it and don't feel it, how do you realize it? How do you take it seriously? I don't live in Antarctica. I don't live in the Arctic, and I don't want to live in the permafrost. And I'm certainly not going to live up in the Himalayan glacier zones. So I'm not going to see this stuff happening. It just doesn't register with me. I write about it, I read about it, I research it. But every day I get up in LA, hey, it's great out here. 70 degrees, blue skies. I feel wonderful. it's hard for me to even absorb, to think this is reality.
Give it a few years, Robert. You'll have an easier time seeing it, I'm quite sure. So anyway, we are, good Lord, all right, we need to be wrapping this up, and I really appreciate this, but this is usually the time in these interviews, Robert, where we get the Hollywood happy ending. I'm not going to name any names on some recent interviews I've had. People who have listened to this channel probably know a few people I'm talking about. This is where you're supposed to come on and say, but there's still time to turn this freight train around. But I don't hear a whole lot of optimism in Hollywood happy endings coming from Los Angeles, California today.
No, and there are. I want to be just honest about it. There is no happy ending. It's a sad tale. Do the best you can, and just inform as many people as you can, and hold on for dear life.
That's what we're doing here at Collapse Chronicles. Well, Robert Hunziker, I have absolutely appreciate you taking an hour out of your busy schedule. And folks, do you have a website of your own in addition to your essays on collapseofindustrialcivilization.com?
No, I really don't. I don't really promote myself at all. What they can do, though, is they can go to, well, they can Google my name and put in their climate change, and a whole bunch of stuff will come up. But my last name's spelled Hunziker, so Robert Hunziker, and climate change and neoliberalism. I've written about that too. A whole bunch of stuff will come up, and they can see it. And some of these sites, like the UK Progressive and Dissident Voice and Counterpunch, have all of my articles, by the way. They have them in archives.
All right, folks. So I hope you do that. And Robert, we do appreciate what you are doing, fighting the good, lonely fight. And all I can say is keep up the good fight, and hopefully we'll come back and talk to you in about a year or so and see if things are progressing along in the great acceleration like you and I both think they will be. But we want to thank you very much.
Okay, great. I look forward to that.
Stick around for just a minute after I'm just going to say bye to the folks, and I want to come back and just wrap this up with you. Anyway, guys, thanks for joining us on another edition of Collapse Chronicles, and hopefully we will be doing this again next week. Bye, guys.